Okay, in the last videos, I explained what we are going to do in this chapter and what we need to know or why we study the regression model. Well, let's do it more seriously. Let's study the linear regression model in a formal setup. So usually the left hand side we write the regression equation in this way. yi is the ith observation, the value of y variable for ith observation. And beta 0 and beta 1, xi is also ith observation's value of x variable. And ui is the error that is associated with the ith observation. And in this case, we have n observations. In our previous examples, we had 50 schools or school districts. 50 schools, so n is the sample size, which was 50, and x was student-teacher ratio, y was test scores. And so school I has, we observe school I's student-teacher ratio and test scores. We called x as the independent variable or regressor, or sometimes explanatory variable, because x, the role of x is to explain the y. So we would like what we are in. So if you imagine test score is here and student teacher ratio is here, then basically implicitly we assume that the test score is a result of student teacher ratio. So in other words, student teacher ratio can explain the change in the student teacher ratio can explain the change in test scores, right? So in that sense, x, the student-teacher ratio, affects y. So the causal relationship goes this direction, cause and effect, right? So x is called independent variable or explanatory variable. It is not affected by the other or regressor. And on the other hand, y, the test score, is called as the dependent variable because test score is determined by the student teacher ratio. So it depends on the student teacher ratio. So y, usually the dependent variable is written on the left hand side and the independent variable is written on the right hand side. So yx, or so like later like we may call like y variable, x variable, or left hand side variable, right hand side variable, because this equation is so universally the same. Pretty much every textbook uses the same form like this. So and you are going to see the same equation in many different places with little variations. Anyhow, so the names are given that way, and beta 0 is the intercept. So intercept is a mathematical term. So intercept means the value of y when x equals to 0. So if everything else is 0, all the other variables equals to 0, then y will take beta 0. So that is the intercept. So intercept may be of interest or may not be of interest. In this case, in our example, beta 0 does not have its own meaning because in our example, beta 0, the intercept means the value of expected test score, if student teacher ratio is 0. But x never takes 0, and so the intercept itself has no meaning at all. So in that sense, it's not important. But if you want to predict y, you need to know beta 0. So what is the expected test score if the student teacher ratio is 20? Then you need to know beta 0 and beta 1, right? That in that case, beta 0 is required. But also, beta 0 is not required. In some cases, beta 0 is not required. For example, the current student-teacher ratio is 20 in this school. Then what would be the increase in the test score if the student-teacher ratio drops by 2, for example? In that case, you are looking only for beta 1. So beta 0 does not play anything, is nothing. You don't need to know that to answer that question. So in that sense, the beta 0 will get less attention than beta 1. So most of our analysis, most of our attention will be devoted to beta 1. And almost the same methods can be applied to beta 0, but the main focus will be on beta 1. So beta 1 is the slope. When x increases by 1 unit, y will increase by beta 1. If beta 1 is negative, that means y will decrease, right? So if x and y move to the other direction, then beta 1 will be negative. In our example, student-teacher ratio, increase in student-teacher ratio will decrease the test score, so beta 1 will be negative. So higher student-teacher ratio means lower test scores, so beta 1 will be negative. And finally, the error term, the regression error, ui, is literally an error. Of course, it is not observed. So you may understand it in many different ways. Typically, we are going to put this interpretation. So you only, in our data set, in our imaginary data, no matter how many observations, still the problem is we only have two variables, test score and student-teacher ratio. But there are a lot of factors that affect the test score. So test score is affected by student-teacher ratio. That is true. But it is also affected by many other factors. Like, for example, the simplest example to interpret U is the difficulty of the test. I don't know how the test questions are generated, but suppose that the difficulty may fluctuate. So then difficulty itself could be another important factor of the test score. So, but however, difficulty cannot be measured or is not observed in your data. So then you have to put it into the error term. Everything you cannot observe, you don't have, but affect y is included in the error term. So just like a kitchen sink, everything is thrown away, to the error term. So like say school, like say average family income, or like say average subsidy from the government, or whatever, like school, like teachers, like teachers' salaries. There are a lot of other factors anyhow that should enter this equation, but we cannot put those into the error term, right? Another example could be measurement error. So test score may have an error, I don't know, for some like rounding error, or maybe there are some outliers, say some students or absent or something like that. So anyhow, everything else goes into this error term. And then in the graph, you may think it this way. Student-teacher ratio so usually X, the independent variable, explanatory variable, or the regressor goes to the horizontal axis, and dependent variable on the vertical axis. And this is the same regression line, like similar. You can understand the regression line, as in the same way as I introduced the motivating example. And suppose there are 7 observations, and then so the true regression line, population regression line, goes like this. However, there is no observations exactly on the line. So observations deviate from the true regression trend. The reason is because of the error term. So for example, the first observation has 15 student teacher ratio. So the school is expected to perform this level, say around 660. However, for some reason, for some unobserved reasons, the school is doing much better, outperforms the expectation. So a positive error happens. But the second school has this much student teacher ratio, then this school should have performed this level. However, it's below our expectation for some reason, for some unknown reason due to the error term. So the deviation can be understood as the error terms. Okay, and then we set up the terms and I introduced terminology for the regression. In the next slide, I'm going to explain how to compute beta 0 and beta 1 using the data. And we are going to use the least squares idea, which I introduced in the previous lecture. So it's not that difficult. The idea is intuitive. So I'm going to continue that, go to that topic in the next video.